Hello, this is Michael and Zach, programming language group 8, project 4. So our language is Go, and Zach's going to start off with the history.
Yeah, so we're doing Golang, and a little bit of the background is that it was created by Google, and it wasn't created by Google to do any research in the programming language area of computer science. Rather, it was actually to help software engineers. They're experiencing a lot of troubles with how they were building like scalable systems for web. And so a large focus of Go was to help improve build speeds, uh, help with the scalability issues, and abstract some difficult parts of programming like concurrency and dynamic allocation. And so some of the requirements they wanted it to be C-like, but it wasn't supposed to be completely C-like because the developers didn't really like C++. And so Michael later will go over some features that are not in Go and are in C++ because of that reason. And they really wanted it to be modern. They didn't want it to be dated like C. At least in their opinion, they thought C was dated. So really, this program was built out of need for Google to have more efficient and productive programming on their website and have that scalability that they wanted.
So Go is a compiled language. The source code gets compiled into a binary executable, which is optimized and checked for errors by the Go compiler. So in this case, the code can run very fast after it goes through compilation. Go is also an imperative language. Uh, More specifically, it takes functions that are built out of statements, which are generally phrased as like imperative commands, such as variable assignments or instantiations. This makes Go different from logic programming languages like Prolog, which we learned that have explicit logical rules, or functional languages like Racket, because Go can hold state within the program in a way that Racket isn't able to. In terms of memory management, this is sort of where it gets interesting. The difference between Go and C++, which sort of inspired Go. Uh, Go only offers automatic dynamic memory management. So it has a garbage collection mechanism under the hood. So this garbage collection mechanism allows Go to have an increased level of security, a better portability, better portability across operating systems. There's generally less code to write, and there are balance checks for things like accessing arrays and their indices. And this is where you can see, the developers of Go didn't like the fact that C++ had sort of a manual memory allocation process for the heap.
Yeah, no one likes C++.
No one likes C++. Uh, so now going on to types, Go has a number of built-in types. Some of them are numeric ones. For example, byte, int, int64, floats, float 32, booleans, and byte strings. Now, the strings in Go are immutable, which means that any string operation that, for example, concatenates two strings under the hood would require the creation of a completely new string based on the two given strings. And these string operations are done through built-in operators and keywords instead of functions that other languages sometimes use. And you also cannot overload operators in Go because the developers did not like C++. No, you can overload operators in C++. So the developers of Go didn't like that, so they took that away. Go also has static array types and also dynamic array types. Now, dynamic array objects in Go are specifically known in the language as slices. They are allocated on the heap, and the programmer gets access to a reference to the array on the heap that they can use for our program. So we use these dynamic arrays, these slices for our project, and we access our array using the references that the program and the language gave us. Which also brings us to parameter passing. When we passed our arrays and our matrices that represent the Sudoku board into the different functions that operate on the Sudoku board, we pass them in with the reference to the arrays. So we pass them in by reference. But another option in Go is to pass parameters in by value. I think we did that in this case with some of the basic ones, such as for example, when we want to pass in something like a number or like the row or the column in a specific array, I think those were passed as a value instead of by reference.
Mm-hmm.
So now Zach will talk about some of the pros and cons of what we ran into when we were trying to write this program.
Yeah, so some of the pros is that it was like it was very familiar to us. It was the syntax was a lot like C++. Despite it obviously having a lot of differences from it, it was familiar in syntax. However, we found some challenges when we were reading from the files, particularly because the type was it a byte array?
Yeah,
It was a byte array, yeah.
bytes.
It was an array of bytes. And so when we were doing the data processing, it was a little bit confusing on how we were supposed to actually process that data. We figured it out through trial and error, but it was something that we had never seen before. So that was mildly confusing.